Good morning, everybody. All right. So today is going to be on lesson 6. You'll notice that we did skip lesson 5. It was just redundant of lesson 4, so didn't want to beat the horse dead, So we are scooching over to lesson 6, which is the zero product law, which should look familiar from Algebra 1. And your homework tonight will be in Delta Math. I'll actually write that down. So homework in Delta Math, and that'll be due on Monday, which is also going to be when your next lesson is. So Monday, I'll post it in Teams. I believe I said 11:50. It's either 11:15 or 12:15. I can't remember offhand, but I'll post it in Teams for your next lesson. So hope you're all having a great day. Some of you are probably just waking up. All right. Sorry, kind of like got to maneuver around this microphone. If I go off by mute by any chance, I might not realize it, so just let me know in the chat. All right, so the zero product law. If A times B equals 0, then A or B must be equal to 0. So if AB equals 0, then maybe it's 0 times B or A times 0. How do I get into Delta Math? Justine, if you scroll up in the feed in Teams, you'll see a teacher code, but I can email that to you after the stream. So it won't let you create the account without my information. All right, so the purpose of the zero product law, actually I'll zoom back out, is to find x-intercepts, which as we know, are also called roots or zeros, hence why we set it equal to 0, or solutions. So remember, there's many, many names for the x-intercepts. And the reason that they're also called zeros is because that means that your y value, your f of x value, is equal to 0. All right, so I'll give you a second to copy that down because I know a lot of you may not have a printer. I don't own a printer. Mostly because I feel like I used it 3 times and then like it's out of ink. So, all right, our first example, we're going to solve for x. So for these first few, I'm going to give them to you already in factored form, and then we have to see what the roots are going to be equal to. So some quadratic factored into x plus 7 times x minus 3. What we do is we drop down a t-chart, and we set each of those individual factors, the things in the bubbles, equal to 0. So I'm going to have x plus 7 equals 0. And I'm also going to have x minus 3 equals 0. And then we're just solving for x. So over here on the left, we can subtract 7. So we get x equals negative 7. And over on the right, we can add 3. So we get x equals 3. So those are our 2 roots, or your x-intercepts, at negative 7 and positive 3. And that's it. That's a zero product law. Wham bam. Okay. I'm going to scooch over to the next one. If I'm going too fast, just tell me to slow down. If you're on YouTube, you have the luxury of pausing. All right. So same process of some quadratic was factored into these 2 binomials, and it's set equal to 0. So we're going to drop down our t-chart. And we have 2x minus 5 equals 0, and we have x minus 4 equals 0. And then we solve for x. So on the left, we could add 5 first. So we have 2x equals positive 5. And then I need to divide by 2. So we get x equals 5 halves for one of them. And you can write it as 2.5 or 2.5. I don't really care how you write it. I personally love improper fractions. And then over on the right, it's not too bad. You just add 4. So we get x equals 4. And bam, that's it. Okay. Okay. This next one, it looks like when it was factored, they pulled out a GCF first and then they went into their double bubble. So for this one, we're actually going to have an extra section to our t-chart. So anything that's being multiplied together gets its own section in the bubble. So when we first set this up, we write 4 equals 0. Well, that's just not a true fact. So we reject it. Not true. 4 will never equal 0 in this dimension. Not possible. So the next, I'll change the color. We'll do 3x plus 2 equals 0. And then I got to solve for x. So we're going to subtract 2 first. And then we're going to divide by 3. So we get negative 2/3 as one of the roots. And then our last one, we have 4x minus 3 equals 0. We add our 3 over. And then we divide by 4. 3/4. That's a sketchy 3. I'll fix that. That's a little better. Very good. So still 2 roots, which makes sense because if we have a quadratic, the highest exponent is 2. So the maximum amount of roots I could have is 2. And as we know, some parabolas are only going to have 1 and some might not have any. Okay. Give you a second to get that down. Okay. So next, it says the zero product law can be used to solve any quadratic equation that is factorable. To utilize this technique, the problem solver must first set the equation equal to 0. I'm going to highlight that. First set the equation equal to 0 and then factor. Then factor. So set it equal to 0 and then factor. This highlighter's sketchy. That's okay. So I'm not going to do all of these. I'm just going to do a couple of them. So if you're writing this down, I'll give you that a second. So step 1, set it equal to 0. Step 2, factor. And then, of course, we solve just like we did up top. So I'm just adding in, an extra step or 2 here. Oh, okay. So we've got to factor this into our double bubble. So it's already equal to 0. So that first step's already done for us. We know we can break this up into x and x. Now we're multiplying to get a negative 40, but combining to get a negative 6. Well, since I'm multiplying to get a negative, my signs must be different. So one's going to be a plus and one's going to be a minus. And I got to think, what factor pairs of 40 would give me a difference of 6? Oh, trying to scroll, but it's not letting me. I think the iPad froze. Oh, there we go. All right. So if we think we've got 1 times 40, well, that's not going to work. 2 times 20, still not going to work. 4 times 10, that does have a difference of 6. So we got to think which one has to be negative. Well, if I want a negative 6, that means my 10 is going to be negative. And my 4 is going to be positive when I factor it. And now we can drop down our t-chart just like above. So we have x plus 4 equals 0, which means x is going to equal negative 4. And over here, x minus 10 equals 0, which means then we're going to have x equals 10. And bam, those are our roots. Easy peasy. Okay. It's a little delayed, so that's why I'm pausing so long. All right. Next, we have 2x squared as our first term. So, and it's equal to 0, so I can jump into my double bubble. And the only way to break up 2x squared is 2x and x. Not really any other options there. So we are multiplying to get a negative, and combining to get a negative. Well, since I'm multiplying to get a negative, that means my signs are going to be different. But where we place them is important. I need to get a negative 5, and the only way to multiply to get 3 is 1 and 3. So that means my 3 is going to have to go over here so I can multiply it by the 2. And my 1's going to go here. And since I want it to be a negative 5, we're going to do 2x plus 1 and x minus 3. And if I wanted to check that really quick, I could. This is going to give me 1x, and this is going to give me negative 6x. So I see right there that I am going to get negative 5. Okay. So I'm just going to erase that so I can drop my t-chart, but I wanted to show you that it truly does work. And for some of you who are still getting used to those, don't feel bad if it takes you a couple tries to get it. It's really not a big deal. We're still getting used to those. All right, so now that I got my bubbles, it's equal to 0. I can solve. So we get 2x plus 1 equals 0. So if I'm going to solve for x, I've got to first subtract 1. So I get 2x equals negative 1. And then I need to divide by 2. So I get x equals negative half for one of my roots. On the other side, excuse me, I have x minus 3 equals 0, which means then I have to add 3. So I get, I'm zooming out a little bit. I get x equals positive 3. So there are my 2 roots. So hopefully this is looking a little familiar from Algebra 1. Maybe you did a little bit in geometry. Probably not too much, though, in geo. All right. Let's do another example. I'm going to skip example C and scooch over to D. So in this case, we are not set equal to 0 yet. And I always want to try and keep my leading term with that x squared positive. So I'm going to subtract x squared from each side to keep it positive. I'm going to subtract the 3x from each side. And then I'm going to add 2. So this side all cancels out. But then I'm left with 2x squared plus 9x minus 5 equals 0. What I'm going to do is I'm going to pause for a moment, and I want you guys to see, can you factor this? What would it look like factored? Take a moment and try and factor it on your own. Okay, so hopefully you got a 2x and an x. Now we're multiplying to get a negative 5, so that means my signs are going to be different. Oops, this iPad does not like me. Minus, plus. Okay. And then the only way to multiply to get 5 is just 1 and 5. So minus 1 and positive 5. And let's just check to make sure that works before we go too deep. So we get negative 1x, we get positive 10x. That will give us a difference of positive 9. So it does indeed work. So I'm just going to erase that out because I just wanted to check it. Whee! All right, so now I can drop down my t-chart, and it is business as usual. We have 2x minus 1 equals 0, so I can add my 1. And then I can divide by 2. So we get x equals positive half for one of our roots. And then on the other side, we get x plus 5 equals 0. So therefore, x will equal negative 5. All right. We're going to do one more example together, and then we'll call it a day. Ooh, I sat on my foot too long. Now it's falling asleep. Oh, the pain. Okay. Wow, it is really delayed on my screen. Okay. It says, consider the system of equations shown below, consisting of a parabola and a line. We have y equals 3x squared minus 8x plus 5, and y equals 4x plus 5. So we want to see where the parabola and the line intersect. Find these intersection points of these curves algebraically. So we want the intersection, and we want it algebraically, which means I'm not going to rely on my graphing calculator. Now, of course, you can check it in your calculator and look at the picture. I always let you use your calculator. Side note, if you don't have a calculator on you, if you go to desmos.com/calculator, you can pull a free one up there and use it whenever you'd like. And it'll graph and do a bunch of stuff for you. All right, so if I want to see where things intersect, that means I want to know where are these equal? Where are these 2 points physically equal? So if I want to know where something's equal, that means I'm going to set my equations equal to one another. So that means I'm going to have 3x squared minus 8x plus 5 equals 4x plus 5. And now it's just like that example we did above, example D. We got to first get this set equal to 0. So I'm going to subtract the 4x over. Sketchy 4. I'm going to erase that. It's just too messy. I can't deal. And I'm going to subtract the 5. Now, again, the reason I'm doing this is because I want my leading coefficient, that x squared, to be positive. I don't like working with negatives. So we get 0 over here. We have 3x squared minus 12x, and the 5's cancel out. No big deal there. So remember, when we're factoring, we usually want to check to see, is there a GCF? And in this case, there is a GCF. We get our GCF is 3x, which means what's left inside is x minus 4. And that equals 0. So this one doesn't double bubble, but that's okay. It's just actually a little less work for us, which is kind of nice. And now we can drop down our t-chart since it's not going to factor anymore. My iPad froze again. There we go. Okay. And so, I'm getting a little smushy here. We have 3x equals 0, and we have x minus 4 equals 0. Well, on the left, if I want to get x alone, I just divide by 3, and that's still just going to be x equals 0. And on the right, we have x minus 4 equals 0, so that means x equals 4. Now, I'm not done there because remember, in this case, we're not looking for roots. We want to see where they intersect. So I know that one of the x values is going to be 0 comma, the point's going to be 0 comma something, and then another point is going to be 4 comma something. So we need to plug this back into one of the equations to see where the point is. Well, the linear one, definitely easier to plug into, less work. So I'm going to pick that one. So we have to check when x equals 0. So, what was my original line? We have y equals 4x plus 5. Okay. So we have y equals 4 times 0 plus 5. So y equals 5. So therefore that point is the point 0 comma 5. So they both will intersect right there at 0 comma 5. And then I need to check for when x equals 4. Now I'm going to do the same thing. Plug it in to that line. Now, of course, you can plug it into the quadratic, but that's just more work. Who wants to do that? Not me. So we have y equals 4 times 4 plus 5. So therefore, y equals 16 plus 5, which is 21. So that point is the point 4 comma 21. So the quadratic and the line, when you graph them, that is where they will both intersect. Awesome. And that is all I've got for today. Are there any questions or ones that you would like me to scooch back up to? Okay. If not, I'm just going to let you get a jump start on your homework. Again, it's in Delta Math, and Justine, I will email that teacher code to you so you can get in. There's a couple in there. Some of you were a little bit behind, so make sure you guys have watched the factor by grouping lesson from the other day. And then there's also a Delta Math on that. So, hope you have a fabulous day. I am signing off.